we were discussing about the system analysis, especially requirements modeling part. Under that one, we discuss, or we are intended to discuss multiple modeling techniques. And we discussed how data flow diagrams can be used to show how data flows among various entities. So we discuss about the symbols that we can use. Are the two types of diagrams, actually different levels of diagrams. So under that, we discussed as the first one, how we can represent the whole system in one single page, which we call context diagram. So usually we start with drawing the context diagram where we place the information system in the middle of the page and all the other entities around. So those can be like other system or other entities around them. And then we can use arrows to show the data flow. And we can also mark them, what data flows between these. Right. And then when your number, there's a unique number we can use. For example, we said we can use number 0 to represent the context diagram. And then when you go down into the next level, we say you can go as 1, 2, 3. And if you would go down into one of these, for example, 1, then you can mark the numbering as 1.1, 1.2, 1.3, and so on. So we were discussing some examples as well. So you can see that we have look at the grading system, and around that we have a reporting system, as well as we have student and the instructor. And then the arrows we can represent to use how data flows with all these entities. And also we representing 0, making that this is the context diagram. Right. And then also another example, we are ordering system, where the ordering system process the main information system in the middle and all these other entities around this, and also with arrow showing the data flows and then marking what data flows in these. Right. So then if you want to go into detail, I told you, you have to select the main process. Then you identify the sub-processes inside this. So that's the idea. And in the main process, usually we don't show something called data stores, where we have store the data like in databases or tables. So those will not be shown in the context diagram. So mainly only 3 symbols are represented, all these. So we can have out of 4, that is processes and then data flows, as well as and data stores and entities. So we are not going to show the data store in the first one, that is context diagrams, right? Now, when you go to the next level, then you actually talk about the inner details. For example, if you have A and B coming in and going out from the process, so if you go into detail of this, the same thing should come in and same thing should come out, and this could be go into small sub-processes. Same goes as with, for example, here. If you take this particular process, we will see that there are 2 input X and Y, then there will be output Z. So then if you go into details of this process, there will be a set of sub-processes. But remember, again, the inputs will be the same and output also the same with the previous step. So that's what we have discussed so far. Right. So we discussed a couple of examples going from grading system to go into details. In this particular case, we discuss, okay, we have a grading system. Then we can identify 4 different sub-processes as 1, 2, 3, and 4. So the same information, you can see it here. This will be high level, but this time it will be more detailed, as well as we have data stores. So that's the idea that we have discussed last time. And similarly, when you look at the order system, we have a single process in the context diagram. And then when you go into detail, there will be 3 sub-processors, which means then you have additionally, you have data stores. So those are the ideas that we have discussed. And when you go down into the lower level, there are 2 techniques normally we use. We call leveling and balancing, right? So that means you go into information level. So that means you are, when you're creating, you go into details, and then you can go up to what we call the functional primitives. And when you say balancing, the same figure that we have seen earlier, the inputs and outputs of the parent should be maintained in the child as well. So that is what you have seen in the previous graphic. Right. If you want to go into more detail, for example, our order system, we have order system is break down into 3 sub-processors: fill order, create invoice, payment. And then if you want to go into details about the fill order, then that will go as 1.1, 1 point, and 1.3. And you can see that in this particular case, if you go to the first one, you can fill order, you interact with customer and the warehouse, not with any of the other entities. And that will be the same here. We have customer and the warehouse. So that balance should be maintained, right? Okay. So those are the information. Then also we have to talk about, this is another example where we explore the third process, where we have identified 4 sub-processors as 3.1, 3.2, 3.3, and 3.4. Right. And then I have also given you an exercise you to complete and submit. I will put the link so that you can upload it to the LMS. Right. Today, I'm particularly going to talk about more on other things. The first thing that we want to discuss is data flow diagram. We just finished, and we want to discuss data dictionary and process diagrams. So let's start with data dictionary. So remember, in data flow diagrams, we create several levels which produce the logical model of the system. But you need to provide more details about the data flow diagrams. And that's what we do with data dictionaries. So data dictionary, we can define it as is a central storehouse of the information about the system data. So you can use this data dictionary to collect or to document or organize facts about the system, right? So you can have details like data flows, data stores, entities, and the processes. So those are the things that we represent in the data flow diagrams, right? And you have to describe all the data elements. Okay, so if you start with defining what data elements are, that will be the smallest piece of information when you talk about in an information system. For example, if you take student grade or salary or social security number, something like national identity card number, account balance. So those are what we call the data elements, like fields in a database table. And data record, on the other hand, is the rows. So simply you can say it's the related data elements, right? So when you take a particular record, for example, in this particular example, it says parts 2. You can have things like part number, description, supply code, maximum stock levels, and so on. So that will be a one row of a table. So that's about the data dictionary. So data dictionary can record all the information that we want to have in a data flow diagram. Right. The next one will come as a process description. Now, what do you mean by process description, right? So you have to show the steps in the process. And also sometimes we have some business logic. I will explain what those are with the example. And using these different tools, there are like what we call three things that we are going to discuss. One is we can use simple structured English statements, or we can use it as a table, we call decision table, or you can create what we call a decision tree. So using these three, we can represent the business logic. Okay, let me explain with a simple example. Let's start with the structured English. So if we start with the structured English, we will use English statement to design the process. Right now, for example, let's say you are going to, customer is going to make an order. So customer is going to place an order. So what should happen when customer wants to place an order? It's like you go to a website and you want to order something. Not anybody can order something. You have to meet some, criteria. So here you will see the information. So this says that for each order, that means there could be multiple orders, but we are going to do this for each and every order. So iterative you are going to do. What you do is you check customer status. And if the customer status is good, that means you, pay your bills on time. You have a, positive, uh, credit score. Then we say the customer status code is yes. That is one thing we need to fulfill. You're not going to give everybody the order. So the first part is you check the customer status code. If it is yes, that is one condition. The second condition is the product should be available, right? Otherwise, you can't, get that product. You have to have items in your stock. So therefore, the second thing that we need to do is we have to check the product detail. If you have product details, then we can say, okay, product details are okay. So now you have two conditions you ended. So if you have customer status okay or yes, and product details are okay, then we say, okay, we'll accept the order. If any of these two fails, then we are going to reject the order. So that means customer is not have a good credit score, then we are not going to accept the order. And let's say the customer is good, but still you don't have the product, then you are going to reject the order. So this is a simple representation, like a pseudocode, right? It's like a pseudocode that you use simple statement to elaborate your business logic. Right. Now, there are two other things that we need to consider. So let's look at the other two things. The second one we call decision table. The same thing we can tabulate, right? So when you're tabulating a table structure, we are going to find something called conditions and outcomes. So you tabulate it and you define set of conditions and you define set of outcomes, right? So let's see with the example. Now let's see the same thing. You are going to verify the order with the two conditions. Order will be accepted if product is in stock or customer credit is okay. The same thing as earlier. All the other cases, we are going to reject, right? So now we have to first put up our conditions. By reading this, you can notice that we are checking two conditions. The first condition is credit status should be okay. The second condition is product should be in the stock. So credit status is okay. At the same time, product should be in the stock. Right. Now, based on that, those are the conditions. Based on that, we are going to make two actions. First one, we are going to accept the order, or we are going to reject the order. So what are the possible, right, outcomes for these two conditions? We know that credit status okay could be yes or no. Product is in stock also could be yes or no. So therefore, we know that there are four possibilities. You can say yes and yes. You can have yes and no, no and yes, and no and no. So what do you mean by yes and yes? That means the customer's credit is okay and we have the product in stock, which means that we can accept it, isn't it? Because both are satisfied. Okay, look at the rule number 2. What we say here is, okay, credit is okay, but we don't have the product with us. So we have to reject order. Nothing wrong with the customer's credits, but we don't have the product in stock. Third rule, we have product, but the customer credit is bad. Therefore, we have to reject it. Last one, both cases are not meeting. That means credit says is also not okay. Product is also not available in stock. Again, reject. So you can see we tabulate and we put down all these combinations and we specifically separated as conditions and action. Okay, any questions before we move to the next part? Yes? No questions? Okay, we'll move to the next one. Now we covered two things, structured English. Second one, we have a decision table. So let's move to the next one, right? Okay, so the third one, okay, sorry. Before the third one, okay, we have exercise. Sorry about that. Okay, so you have given an exercise. Let's see how we can handle this, right? Okay, so first of all, read the description and see whether you can understand this. Maybe you can take a screenshot of this, right? Can you guys take a screenshot of this? Okay, so take a screenshot of this. And we are going to use a table structure, right? Right. So now you have to identify two things. So according to this description, we can, by reading the description given to you, we can identify three conditions: preferred customer, order 1,000 or more, use of a charge card. Right? Good. Now, what are the actions? Yes, what are the actions? You can put in the table. I don't have space, so I will just say actions. What are the actions? How many actions you can see? Can you tell me like how many actions? Is it 1? Is it 2? Is it 3? Is it 4? Of course, I put the condition. So the condition, I said customer preferred donor. So that's why I say the first condition is as preferred customer. So that answer could be yes and no, right? So that I have already put. Now my condition is like how many actions? How many actions? Is it 2? Is it 3? Is it 4? How many? Read the description again, think about it. Like how many actions? What are the possible actions? Read the first sentences again. Preferred customers who order $1,000 or more are entitled to 5% discount. And an additional 5% discount if they use our charge card. So you can see 5% discount is one action. Additional 5% discount, it's another action. So now my question is, how many actions? 4 actions, right? So what are the 4 actions? Yes, the actions are 5% discount. Then additional 5%. You can have additional 5% discount. And what? Anything else? Yes, what are the other conditions? Then 25 bonus, right? $25 bonus. $25 bonus. And finally, $5 bonus. $25 bonus. Sorry, $5 bonus. Right? Now, how many rules? How many rules? How many rules? What are the rules? How many rules we can generate? We have 8 rules, right? R1, R2, R3, R4, R5, R6, R7, R8. Right? So there are 8 possible rules, right? Why I said 8 possible? So we can say yes and yes. For example, here, this could be yes, 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 no, no, no. Then yes, yes, no, no, yes, yes, no, no, right? Then yes, no, yes, no, yes, no, yes, no. So these are the full combination. Now tell me what are the discounts we are getting. Yes. So we have 8 possible combinations because we have 3 conditions. So now we can read. Okay, we have preferred customer and order 1,000 and more. And they have used charge card. So now you can say you will get 5% discount. Since they have used charge card, you will get additional 5%. You will get 10% discount there. Then you have preferred customer. You order 1,000 or more, but you don't have our charge card. What happens? You get only 5% discount. 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 5% and you are a preferred customer, but you didn't order 1,000, so you will get 25, right? You will get 25 bonus. Third rule. You are a preferred customer and you have not ordered 1,000 and more. Same. Here again also the same. 25 bonus. Then the rest of the things, you are not a preferred customer. So if you are not a preferred customer, then it's just a 5% bonus. So all these will be 5% bonus, right? Agreed? Read and see. Preferred customer, order 1,000 and more, and they have used a charge card. So the action will be 5% discount plus additional 5%. Your preferred customer, right? You order 1,000 or more, but you didn't use a charge card. So 5%. Your preferred customer, you didn't order 1,000. So 25 bonus. Preferred customer, you didn't order 1,000 or 25 bonus. And all the other cases, you see, they are all the other customers. You will get $5 bonus coupon. Right. Now, one of the problems in the previous one, you can see that we have 3 conditions. We have to have preferred customer, ordered 1,000 and more, use charge card, right? And you can see there are 8 possible combinations. And we know that if the customer is a preferred customer, then we have to check the other ones. But if the customer is not a preferred customer, then we can directly make a decision. We can say that the bonus should be $5, right? And if the customer is a preferred customer, if the customer is ordered 1,000 and more, if the customer is not ordered 1,000 or more, it will be 25 bonus coupon. So you can see that you don't have to check that again here, right? If you compare our answer from the previous one with this one. Then if the preferred customer ordered 1,000 and more or use a charge card, then you have 5% discount plus additional 5%. If they have not used our charge card, it will 5% discount. So you can see the same thing, but this will be very simple, right? So when you compare the decision table, the tree structure, this representation is much more simple. So therefore, most of the time when you compare the decision table, compare with the decision trees, decision tree is preferred. Because you can see there are not many comparison. 1, 2, yes, then 3 and 4, right? 4 outcomes direct, and it's very simple and straightforward. So therefore, it's very simple if you use a decision tree instead of a decision table. Right. So I hope now you got the 3 things. There are 3 ways we have discussed. The first one is you use simple English, we call it structured English. Then we can use a table structure like that, right? Or we can have a decision tree structure like this. Right. Given this, I want you to do, right? What I want you to do is, so please, can you draw the decision tree structure for our previous problem? So what I want you to do is take a copy of this, look at this, the decision tree structure. This is for our second example we discussed. Similar thing I want you to draw for the first one. Shall we try with the first one then? Okay, I hope you got a screenshot of this. Yes. Let me take. So this is the decision structure. Let me share in the chat. Now I want you to draw this for our first example. What was the first example? So if you go back here for this one, right? For this problem, can you draw the decision tree? So in this particular case, we have two conditions, right? So let me say we have credit status is okay. Yes, we can say okay. Credit status is okay. That is one, right? So if it is yes, we have two directions, guys. We have yes and we have no. If it is no, we know that it's reject order, right? If it is no, we know reject order. Then credit status is okay, but then product, whether the product is in stock. So we can check it here, because if the credit is not okay, there's no point of checking whether the product is in stock. So there you can directly say reject the order. Okay. So the next thing here is we can ask, okay, product is in stock. Product is in stock. Let me put this in 2 lines, right? So we can ask whether the product is in stock. Again, 2 answers. We can say yes, we can say no. So if it is yes and no. If the product is not in stock, we know it's again reject. Reject. And if the credit states okay and product is in stock, then accept order. So I hope you got an idea, like you don't have to check multiple times. For example, here we have checking 4 times, but here we actually not check. If the credit is bad, that means if the credit is not okay, then you don't have to check for the product in stock. You can just say it's a reject order. So we simplify the decision making. So therefore, many times decision trees are preferred compared to decision tables. Okay. Final task is, I will give you another question and we'll conclude the session for today. Right. So let's move on to the last one. Okay, small exercise.